Hey everyone, and welcome back. The next topic that we are going to discuss in Terraform is resource lifecycle. Let's see what it's all about and how it is beneficial. Whenever you use Terraform to deploy your resources or manage your resources, Terraform by default, it manages its own, I would say it manages the complete life cycle of the resource. So what do you mean by life cycle? This means that the resources are being created, they are being modified, they are being destroyed. Now, this destruction, creation, modification is dependent on two different, I would say, scenarios or two different files out there. One is the Terraform state file, which captures the current state of the infrastructure. And the other one is the configuration file, which captures the desired state that you would like to achieve. So we can influence this life cycle by using the lifecycle made argument within the resources block. Let's go through the theory first, and thereafter, of course, we'll just put that into implementation and practice and see that how this can be used. Terraform resources by default, they undergo a life cycle that involves the creation, updates, and destruction based on the configuration files and the state of the real-world infrastructure, which is captured in the Terraform state file. This life cycle can be easily influenced and controlled using the lifecycle meta argument within a resources block. There are three different stages of the Terraform resource lifecycle. One is create. So of course, when you run the command terraform apply and you tend to provision the resources through that command. When you change the resources attributes and then you run the terraform apply again, then of course, those resources get modified. You run the command terraform destroy or terraform apply with destroy option or flag. Then you just destroy those resources. So this means that you just execute the actions to influence the life cycle of a resource or resources out there. Now, when these resources are being provisioned, modified, or destroyed, there's a certain pattern that they follow. Now, this pattern that's being followed by default can be influenced, can be controlled by us. And for that, we use something called the life cycle meta argument within the resources block. We'll see that how this can be used. Let's see several sub-arguments. Right now, it will not make any relevance to us. But as you see that into practice, it will start making sense to all of us that how exactly these different life cycle sub-arguments could be used. The number one is create before destroy, which is a Boolean value. When it's set to true, this means that when you just try to enforce the replacement of an instance, or an instance of a resource, the normal pattern is that the older instance of the resource is being destroyed first, followed by the launching of the new one. Now we can reverse that using this create before destroy sub-argument. Then we have prevent destroy, which is in bool, true or false. This prevents the critical resources from being destroyed. Basically, this will ensure that we just give the immunity to one of the resources or multiple resources out there so that they're not being destroyed during any of the Terraform operations. Ignore changes. If you change any of the resources attributes, doesn't lead to the destruction or modification of that resource. Replace triggered by. Two resources are interdependent on each other, and you want to make sure that any change in one resource leads to the replacement of the other one. That could be done. And also we have the preconditions and postconditions. We'll take the preconditions and postconditions in a separate topic because we'll primarily focus on these, the first four or the first three sub-arguments. We'll see that. Okay. Let's go ahead and let's put that into practice because again, I can just go ahead and go through the theory one more time, but it will not make that much sense to us as if now because we have to see that how this can be put into the implementation. Then and only we can understand its relevance. Let's go ahead and create a new folder out there. I name it as TF. Let's make it as resource lifecycle. So let's keep it simple. And let's create a Terraform file. And as always, I'm going to just go ahead and just copy and paste the Terraform block and the provider block while changing the region to EU West 1, which is the Frankfurt one. Okay. And just right click and install the plugins. How do we install the provider plugins or initialize the working directory? By running the command terraform init, and that will be done. Okay. Now, all right. So I will just save this again and run the terraform init one more time. Let's go ahead and right click, open the terminal one more time. Terraform init. Okay. So somehow it is not accepting the configuration. Let's try it once. So let me just remove this, or okay, I think might be this file is not created within this folder. That's the reason. Yes, so I'm going to just drag and drop it again, move it, and then I will just run the terraform init one more time, and this is being initialized, right? So I just moved the main.tf file outside the project folder. That's the reason it was not initializing. So that's being sorted out. Okay. Now, what's the next thing? We'll have one approach over here. Based on that approach, we'll have two resources being configured. The first resource would be a security group, and the other one would be a resource that would be an instance, which would be, I would say, dependent on upon the security group. So we have the security group, and then we have the instance deployed. Instance will be dependent on the security group. So we'll have kind of an implicit dependency being enforced right now, so that we can see one of the sub argument, which is the replace triggered by. We'll see that. Okay. So let's create a resource. The first resource would be the security group out there. Let's name it as a resource, I would say lifecycle -SG. Tags is equal to, let's assign a tag value. This is my lifecycle-SG security group. So let's copy and paste this tag value as it is. Any security group that you just create, you have to, of course, include the ingress and egress rules. So I just include the ingress, the inbound rules first. And of course, I have to define the from port, which is the 80, and then to port, which is the 80, and the protocol. So the protocol that we are going to define would be TCP. And then we have the CIDR blocks. Then we'll just include 0.0.0.0/0. Fine. I just copy this ingress block, just paste it over here, and just make it as port 443 for the HTTPS, and REST protocol and the CIDR blocks will be as it is. So we have two ingress blocks, two inbound rules. One allows the traffic over port 80, which is for HTTP from all the sources. And the same goes for the other one. It allows all the traffic over port 443 from all the sources. Let's go ahead and define the egress block. Now, egress is for the outbound. And from port would be 0. This means all the ports. So from port to port 0 means all the ports. Protocol would be -1. So this means all the protocols. And CIDR block would be to all the destinations, 0.0.0.0/0. Okay. So based on the egress block, it allows all the traffic outbound to all the destinations for all the ports. So this has been configured without any issues. Let's go ahead and deploy, or I would say create a resource block for the EC2 instance. So this is my AWS_ instance, and I just name it as, for example, let's make it as lifecycle_instance, right? So let's name this resource block as it is. And what's the first thing? The first thing we want to include, it would be the AMI. So I'm just going to copy and paste the AMI from the AMI catalog, which is within the Frankfurt. So, okay. All right. One thing I did by mistake is I made it as EU West 1. So let's make it as EU Central 1. Okay. So that's the thing I want to change. All right. So in the meantime, I just go to the AMI catalog and change the or I would say copy and paste the AMI, and let's do that. Fine. And what about the instance type? Instance type would be, so the instance type that we're going to choose would be the t2.micro instance type, which is free tier eligible. So you can use either t2 or t3.micro because both are free. I would say not free entirely, but of course they are being subsidized in terms of using it under free tier category. So again, if you pay for them, the charge is very less. So you can use either t2.micro or t3.micro or t3.small, whatever you want. Tags, we're going to just tag it so that this could be easily recognized. So tagging is important for resources identification. So it's always the best practice to tag the resources out there so that you can identify the resources once you launch them. So I'm just going to name this thing as, for example, let's make it as lifecycle_instance. All right, let's keep it as simple. Now, one thing we need to be very cautious of in terms of execution is that once you define AMI instance type tags, everything, we want to ensure that apart from the AMI instance type and tags, there's one more thing we want to include, which is the security group. So I just go ahead and say VPC security group IDs is equal to then a list of security groups. Now, why we are including the square brackets? Because the square brackets in Terraform represent a list. You can attach up to 5 different security groups to an instance or a load balancer. So over here, the security group we're referring to is this one, the top one. So AWS_security_group dot lifecycle_SG. You can see that, but we have to include dot ID. So I'm saying that this instance is going to be launched or accessing the security group ID of this security group, but it's being declared through this resource block. Fine. So this is kind of an implicit dependency that we are enforcing. Okay, this is a classic case of or example of implicit dependency that we have already enforced. All right. Now, what's the next thing? The next thing is that we are going to just go ahead and launch these 2 resources first, and thereafter we can use the I would say lifecycle block. Okay, so that's the one thing. Let's go ahead and include the lifecycle block first, and then of course we can execute everything. That will be much more appropriate in this case. So lifecycle is a block that we are including within the instance block only. The very first thing we include will be create before destroy. I'll set it to true. Okay, that's it. I'll not include any other sub argument as of now. Let's go ahead and run the command, which is Terraform fmt to format everything, Terraform validate to make sure that syntactically and logically everything is correct. And let's run the command Terraform apply and auto approve. Of course, I have to give the consent to make sure that these changes are being approved from my end before they're being put into execution. Let's wait and watch. Let's see that it's launching everything. And I think in next a few seconds, everything will be deployed. So as you can see, we have just created 2 resources, and we have declared an implicit dependency, or I would say we have tightly integrated the 2 resources together. This instance is using the security group ID of this security group, which is deployed to the resources block. All right, it's being done. Now, as you can see, if I just go back to the instances right now, instances dashboard, you will see that the instance would be launched. As you can see, it is being provisioned successfully. I go to the security. This is the security group ID. Click on that. And as you can see that this is the security group with the inbound rules which allow the HTTPS and HTTP from all the sources, and outbound all the traffic for all the ports, for all the protocols to all the destinations. And as you can see the tags, it is lifecycle-HG. So this is the security group which is applied to the instance at the time of instance being provisioned. So these two resources are being provisioned successfully with a success. All right. But as if now, this lifecycle block, let me just go back. This lifecycle block has not been executed. This lifecycle block includes a sub-argument which says create before destroy is equal to true. Now, what do you mean by this? What exactly is meant by this create before destroy is equal to true? There could be a possibility that I would like to launch a new replacement of this instance. I want to enforce the replacement of this instance. How would I do that? So we have something called Terraform taint, which is kind of deprecated now. So we use the replace flag. So I run the command. Let's suppose I run the command. Okay, let's do one thing. Let's run the command Terraform plan, then replace. Okay, let's do one thing. Terraform state list. Let's run the command Terraform state list. This is my instance being launched. So I say Terraform plan replace is equal to, and I just copy and paste the resource address of the instance. So Terraform state list shows me the list of resources being tracked by the Terraform state. That's because these resources are being managed by the Terraform. So Terraform state list will show me the list of resources that's being tracked by the Terraform state file or Terraform state. So if I just press enter, it will show me that based on the execution or replacement plan, what's going to do. Let's see that. Terraform used the selected providers to generate the following execution plan: create replacement and then destroy. So it is saying that I'm just going to go ahead. I'm going to just go ahead and just create the replacement first, which means I'm going to deploy the new instance first and then destroy the older instance. Older instance means, or I would say the older version means that this is the older one, right? So this means that the new instance will be launched first and the previous one will be destroyed. We are influencing the life cycle. If we don't do that, okay, let's do one thing. Let's comment it out. So the life cycle block is commented out. It is not, I would say, it is not into the place of, or not in the position being activated, or it will not do anything now. So we have just commented this thing out. So Terraform will execute this thing. And now when we comment it out, if I just try to run the Terraform plan again, you will see a Terraform plan with replace flag. Now you're going to see that it will be reverse. In this case, it will destroy the instance first and then create the replacement. It will be a completely reverse process that it's going to follow. Now you can see that. It will just destroy and then create the replacement. Because I've commented out the lifecycle block, it is no longer valid now. So this means that by default, the resource lifecycle is that if I just go for the replacement of any resource out there, by default, that older version is destroyed first, followed by the launching of a newer version, right? But if I include this lifecycle block, by including this sub-argument, create underscore before underscore destroy is equal to true. So in that case, if I just try to replace this instance, you're going to see that it is going to provision the newer version of that instance first, followed by the destruction of the older one. You can see that. So create replacement and then destroy. So create the newer version first and then destroy the previous one. Okay. And now if I just do it false, for example, instead of commenting out, you will see that the reverse would be done. In that case, in that case, it will follow the normal course of action. What's the normal course of action? That the existing or the older resource will be destroyed first, followed by launching the newer one. You can see that. So in this case, destroy it first and then create the replacement, right? So you can just influence it. You can influence it. So I'll just go ahead and set it to true, and you're going to see once I execute it. So I just run the command. Let's clear everything out. Sorry. So let's clear everything out. And now, instead of Terraform plan, I will just run the command Terraform apply with the replace flag. And I'm going to just replace this. Now, in this case, I'm going to show you on the AWS management console, the new instance of that resource will be deployed first, followed by the destruction of the older one. Let's try to execute this thing and put into action. All right, so I just give a consent. And now let's wait and watch. You're going to see that it's right now behind the scenes, it is creating the instance. It's not destroying the previous one. All right, it is creating the instance first. You can also see that on the AWS management console, as if now a new instance is initializing. Once this is successful, the previous one will be destroyed. Okay, so we have influenced the resource lifecycle. By default, it was supposed to destroy the existing one first, followed by the provisioning of the newer one. But because I've influenced the lifecycle, I've said create before destroy is equal to true. I've reversed that procedure. I'm saying please deploy the newer instance of that resource first, and then destroy the previous one. Now, how it is helpful? Basically, this prevents the downtime. Right? I want to make sure that there's no downtime in terms of going for the replacement. I want to make sure there's no downtime out there. And as you can see that the older instance is removed. Fine, it's being terminated. Right? So this is how we can go about doing that. So let's go ahead and comment it out, and let's go let's discuss the other sub argument, which is prevent destroy. All right. So I'm just going to go ahead and say prevent destroy. Prevent destroy is equal to true, right? Okay, now if I don't use prevent destroy, what happens? So if I say Terraform plan destroy, so it will show me that it's going to, okay, so if I say Terraform apply destroy, okay, so let's go ahead and destroy everything. Or I can say, let's plan it out first. I want to make sure that I can see the execution plan first. And let's see that. All right. So this will just show me the execution plan in terms of destruction. All right. Now, if I run the command Terraform destroy going forward, it will destroy two resources. Of course, we have two resources out there. One is the security group that will be destroyed eventually. And the other one would be the instance that will be destroyed. Now, I want to make sure that if I lead to destruction of any resource out there or replacement of any resource, especially in terms of instance, I want to make sure that the instance is never destroyed. I can say prevent destroy is equal to true. All right. Now, when I turn on this thing or enable this thing, if I run this command Terraform plan destroy again, now in this case, it will not destroy the instance. The execution plan will show that it's not going to destroy the instance. And you can see that. Plan 0 to add, 0 to change, 1 to destroy. Instance cannot be destroyed. So out of two resources, only one resource will be destroyed. That would be the security group, because I've given the immunity to the instance that it's never destroyed. Okay. Now let's do one thing. Let's try to replace the instance now. I just run the same command Terraform apply with the replace flag, and you will see that it will not do anything. The reason being because it's being given the immunity from this destruction. But once I set it to false or comment it out, it's the same thing. If I just comment it out, by default, the normal life cycle is that it should be replaced. It should be replaced. Fine. So in this case, it will be replaced. So you can influence it using the lifecycle block or the meta argument, which consists of the sub arguments. So in this case, if I say prevent destroy is equal to true, so I immune the resource from the destruction during any of the Terraform operations out there. The next one that we're going to see is the replace triggered by. When we configure these two resources block, we could see that this resource block or this resource, which is the instance, is kind of dependent on the formation of the security group, because there's an implicit dependency between these two resources out there. Now, I'm saying, or I want to say that any change made to this resource, which is this security group, will lead to the replacement of the instance. Let's try to put that into practice and see that how this can be put that into the implementation. I'm going to go ahead and change the security group. For example, I can change the ingress rule to the egress rules. Let's do one thing. Let's go ahead and change the port number. I'm going to change the port number 3306 for the MySQL and 3306, something like that. Okay, so I've just changed this thing right now. Let's run the command Terraform plan, and it's going to show me that it's going to just do one change or perform one change, which means that it's going to just change one of the ingress rules of the security group. You can see that plan 0 to add, 1 to change, 0 to destroy. And you can see that this is what's going to change. Let's make this change right now. So Terraform apply auto approve, right? So this change is being done without any issues out there. This is a normal course of action that needs to be followed to change any of the resources out there. And you will see that very soon this will be changed in the next few seconds, because if I go to the security group right now and just try to click on this thing and go to the inbound rules, you will see that this change is getting reflected. That's just a matter of just a few seconds only. Now over here, this change has not triggered the replacement of instance. And this is the kind of a normal course of action. But I can influence it. I'm saying that any change made to this resource will lead to the replacement of my instance. To cut the story short, or I would say to put that into other words, any change to my security group lead to the replacement of my instance. So the modification of the security group will lead to the replacement of the instance. How we can do that? This could be done using this sub-argument replace triggered by, and I automatically include the security group over here, the resource address. This resource address belongs to this resource block. Fine. Now let's see what happens. If I just run the Terraform plan right now, nothing will be done because, of course, I haven't made any change. So I run the command Terraform plan. There will be no changes at all because we haven't done any change to the resources out there. There will be no changes that will be implemented. Fine. Now, I'll make this change to the ingress rule and I'll just take it back to 443, reverse it back to 443, which is for the HTTPS. I just make the correction out there. Okay. Now, technically, or logically, I would say that only the ingress rule needs to be changed. Only the security group needs to be changed. However, because of this replaced underscore trigger underscore by sub argument, the instance will be destroyed and a new replacement will be initiated. We can see that right now. So say Terraform plan, and as you can see that once I just run the command Terraform plan, the execution plan would be displayed on the screen. Let's wait and watch and let's see. When to change? Of course, the security group needs to be changed. When to destroy and when to add. So the security group is just changed. However, this leads to the replacement of the instance as well. Right? You can see that Terraform will perform the following actions. The instance will be replaced due to the changes in the replace triggered by. Because of this replace triggered by sub argument within the lifecycle block, this instance needs to be replaced if this security group is being modified, which is true in our case. So let's do that. Let's run the command Terraform apply auto approve. Let's auto approve the changes to give the consent. And you're going to see that this would be this will lead to the change of the secret group, followed by the destruction of the instance, and then followed by launching a new one. And as you can see that my instance is getting destroyed. Okay, let's wait and watch. Let's see what is happening. In the meantime, let's take a look at the instance dashboard. We can see that the instance is getting destroyed. And of course, once it is shut down, it's terminated, a new instance will be launched. And if I go to my security group as if now, let's see whether the change is being implemented. Yes, the change is being reversed to HTTPS 443, the same ingress rule. And of course, I'm going to just go ahead and you can see that the new instance is being launched. Fine. So this was a crux on the resource lifecycle. This was an overview, I would say that how you can influence the lifecycle of your resources by using the lifecycle meta argument and using these sub arguments, and you can influence the lifecycle, and you can just deviate from the normal course of action to just reiterate or rephrase or to just revise everything what we have done. Create before destroy will make sure that the older instance is destroyed afterwards. I would say that the new instance of a resource is being provisioned first, followed by the destruction of the older one. So this prevents the downtime. Prevent underscore destroy will give the immunity to the resource out there. It prevents the destruction of any resource during any of the Terraform operations. Replace triggered by, basically it ensures that any of that resource which is being modified leads to the replacement of this specific resource out there. So in this case, when the security group is being modified, this leads to the replacement of the instance. So that's it. Thank you so very much.